All right, number 10. What is the volume in liters of each of the following at STP? At STP, at standard temperature and pressure. So that means we can use the standard molar volume. That says, at STP, 1 mole of any gas occupies 22.4 liters of space. So anytime we're at STP and we're using units of moles, we can immediately convert into volume, or vice versa. So for number 10, we're going to go from moles into liters, and you guys can peek ahead. For number 11, you're going to convert from volume into moles, right? So we're going to be doing this both ways. Number 10, we're going from moles into volume. So simple conversion factor. For every 1 mole of a gas, there's 22.4 liters. Moles cancel. I'm left with a simple calculation. You know what? I can do that in my head. I'm going to show you how smart I am. This is 22.4. B, I'm going to set it up the exact same way. I need to cancel these moles and get into liters. But now I actually get to use my calculator because I can't really do that in my head. I mean, I totally could. I just don't want to right now. Totally. Whoop. Right, we get 78.4 liters. Again, 3 sig figs used in these problems, so I'm reporting my answers with 3 sig figs. Again, this is still 3 sig figs here. Don't sleep on that. Report your answer with the appropriate number of significant figures. Again, for every 1 mole of any gas at STP, we're at STP, so that allows us to use this exact relation. If we're not at STP, we'd have to use the ideal gas law to calculate the values we're going for here. But at STP, we can just use this simple conversion factor. 1 mole occupies 22.4 liters. That mole is going to cancel. So 0.0400, you don't really have to type in those last zeros, but times 22.4, with, let's see, 3 sig figs, 3 sig figs, so I guess I'm just going to keep all of those, and I guess you could put that into scientific notation, but just say I don't care enough. Liters, a little bit less than 1 liter right there. And lastly, we got scientific notation, and that exponent right there is going to be such a pain. No, it's not. Let's stay conceptual here. 1 mole is equal to 22.4 liters. The mole is going to go away, and when I plug this into my calculator, I'm not going to deal with this times 10 to the negative 6. I'm not going to deal with it. Okay, I'm going to leave that for afterwards. So 1.20 times 22.4. Now 3 sig figs, I need to turn that 8 right here into a 9, right? So I'm going to go 26.9 times 10 to the negative 6. Okay? Now you guys can see that this is not in proper scientific notation. I have to move this decimal over 1. Now, why am I moving the decimal over 1? Because this value right here, that 26.9, is too large to be in proper scientific notation, right? It has to be between the values of 1 and 10. This is above that. It's too large. So, when I move 1 decimal place, I have to change my exponent by 1. And I have to change it so that it represents the fact that this number got bigger. Well, this is a negative number, so 1 larger than negative 6 is negative 5. So your final answer here is 2.69 times 10 to the negative 5th power.